Bismillahirrahmanirrahim. I am Hammad Shahzad from Comsats University Islamabad Wa campus, and I am representing my team in Itbmdc 2022. This project involves an architectural, structural, modeling and designs of a tall building with conditions relevant to our campus, while taking energy efficiency, water efficiency, and COVID scenario into consideration. Why are tall buildings required? This is due to the tremendous growth in the population in the recent decades has driven individuals to migrate to larger cities in search of better living conditions. This is known as urban migration. According to United Nations, cities will house 68% of the world's population by 2050. This is a dramatic increase that will result in scarcity of the land and natural resources. Furthermore, due to the increasing demand, real estate prices will be experiencing hyperinflation. As a result, tall buildings allow us to build higher while conserving precious land and other natural resources. This is the scope of our project. These were the design considerations that were in our minds while designing the building. These include aerodynamic design, maximum sun's impact for energy generation, and smooth diversion of wind. While gathering spaces, substantial natural lighting, vegetation, and ventilation in the interior, and COVID SOPs in the interior. These are the salient features of our building. We have emphasized the learning through collaboration, concentration, and contemplation by providing the gathering spaces and individual discussion and individual study rooms. We have also ensured the substantial amount of natural light in the interior. The architectural design. This is the exterior of our building. The floors are rotated up to 20 degrees relative to the ground floor with an interval of 5 degrees. This will improve the aerodynamics of the building. These are the specifications. Interior design. This is a story breakdown. The 7th to 26th floor of the building will include classrooms, large discussion rooms, small discussion rooms, postgraduate workstations, and seating arrangement at the corridors. These are the plans of the floors. This is a floor plan of the 26th level. It includes classroom for 30 students, for 50 students, large discussion rooms, small discussion rooms, workstations, and the periphery corridor, along with internal corridor. Similarly, the library also includes a corridor for air crossing. These are the floor plans of the workstations, which are on the 27th floor, and the lecture offices, which are on the 28th floor. These are the pictures of the classroom with 50 students capacity, classrooms with 30 students capacity, small and large discussion rooms, the library, postgraduate workstations at the 26th floor, lecturer offices and cafeteria, and restrooms. Structural design. We have used a shear wall system and supplemented it by internal beams and periphery columns. The key structural members of this structure include a core shear wall, supplementary shear walls, periphery columns, and beams. These are the sizes of the members which pass the design checks in ETAP software. We have used a pile foundation with mat. It was modeled in CSI SAFE. These are the technical details. Structural design. The load transfer at the interior of the building is done by slabs to beams and to shear walls. While at the periphery of the building, as the floors are relatively rotated, so the columns are staggered as compared to the upper stories. So the load will go to from upper story slab to the upper story columns, to the bottom story slab and the bottom story columns. Energy efficiency measures. Why we need energy efficiency in tall buildings? This is because the tall buildings consume more energy as compared to normal buildings. There is a perception that tall buildings are anti-environmental because they consume a lot of energy. And these buildings are the future of construction sectors, so we should achieve energy efficiency in them. We have achieved energy efficiency by the three-step process, which is energy savings, passive design improvement, and on-site energy generation. This is the roadmap for achieving energy efficiency, which we will discuss. In the stage 1, we have achieved the energy savings by lighting controls, building management system, and using highly efficient electric appliances. In a second stage, we improved the passive design. The building shape was decided taking into consideration the energy efficiency measures. It have bulged sides and rounded corners along with a courtyard opening to improve the airflow in the building. The aerodynamic design, the floors are relatively rotated for improved aerodynamics as compared to the ground floors. The improvement in passive design, the facade enveloped, we have designed the facade in 2 layers, which is on a double skin glass facade. The first layer will be composed of the solar panels, while the second layer will contain the double glazed glass curtain wall, which will be insulated. The cavity between these layers will act as an air corridor, which will reduce the air, which will ensure airflow between these layers, which will reduce the temperature inside the building. We have also used a stack effect by providing openings at the key locations. This will improve the airflow of the building. We have used these openings and covered these openings with glass, porous glass, to hide them from the exterior. We have located the maximum building's thermal mass at the periphery of the building. This will result in the absorbance of heat during the daytime and reduction in the peak air temperature at the inside. It will also contain a green roof, which will be used for mitigation of the heat island effect. The third stage is energy generation. We have generated the energy through solar power and wind power. The wind turbines will be mounted at the roof in the prevalent wind direction for energy generation. Reduction in carbon footprint. We have achieved a reduction in the carbon footprint by these techniques, and we have utilized the waste materials in the concrete to reduce its carbon footprint. We have also carried the life cycle assessment study on the concrete, which was used in the building. The results shows that there is a decrease in the global warming potential by 32%, ozone depletion by 29%, water depletion by 38%, and agricultural land occupation by 19%. Water efficiency. The rainwater, we have used these water efficiency techniques in the building, these are rainwater harvesting, grey water recycling, and other measures such as electronic taps. We have improved the indoor air quality by minimizing the lighting pollution and enhancing the thermal comfort. These are the techniques we have used, which are already discussed. These are the measures which were taken for the COVID SOPs. We have also installed ultraviolet bulbs in the ventilation ducts to kill the bacteria and improve the air quality inside the building. And the visual comfort of the building is enhanced through proper vegetation into the green courtyard and the neutral color scheme. The plants will be provided at the intervals between the sitting spaces. From now onwards, the interior walkthroughs are displayed in the slides.